Students, this is a help video for the take-home practice quiz 8.5 through 8.7. Put your finger right there. I'd love for you to read this out loud as I read. An oil tank has to be drained for maintenance. The tank is shaped like a cylinder, 5 feet long, with a diameter of 1.6 feet. Suppose the oil is drained at a rate of 2.5 feet cubed per minute. If the tank starts completely full, how many minutes will it take to empty the tank? Use 3.14 for pi. Round your answer to the nearest minute. So if you want to get all your moving parts, first off, we have a cylinder. And it says it's 5 feet long, which means what happened technically is that they rotated the cylinder this way. And 5 feet long technically is going to be the height. Diameter, 1.6 feet. And then we have a flow rate of it being drained, if you will, drained. So we're draining at a rate of 2.5 feet cubed per minute. Volume equals base times height. Always trace your radius here. A radius is half of 1.6, which is 0.8. Always trace your radius. So that's 0.8 squared times your pi, which we're going to use exactly and only 3.14, times our height, which is 5. That's going to get our volume. So 0.8 squared times 3.14 times our height, and we get 10.048, and that's going to be feet cubed. And it says do not round any intermediate answers, so our rate is 2.5 cubed feet per minute. So that means we divide by 2.5 the rate. It says round to the nearest whole minute, so we get approximately 4 minutes for that tank to drain. Find the volume of a rectangular pyramid. Pyramid. So area of the base, that's a rectangle. In this case, that's 9 times 4. Key to multiplying is not multiplying, so I'm going to take that 3 into 36. And we get our volume is 60 inches cubed. Find the volume of a cone with a base radius of 5 and a height of 6. Write the exact volume in terms of pi. Correct units. So our volume here is area of the base. And it says exact terms, so that's pi r squared. Trace your true height over 3. The key to multiplying is not multiplying, it's factoring. 25 pi times 2. Correct answer here, volume equals 50 pi, check units, meters cubed. The cone and the cylinder have equal heights, and we're going to compare the following. So we're going to be finding, look down below, the volume of the cone and the volume of the cylinder. So step one, we're going to find the volume of both, and we're going to do this in pi form. Doesn't specify whether pi form or not pi form. Pi form's easier. So volume here is base times height over 3, and volume here is base times height. Our volume, our base, we were given, look very carefully, this was a little tricky, that's not a radius, that tells you your base is already that area squared, 11 meters squared. So it's kind of cheating. You don't have to worry about pi form. So that base is 11 meters squared. Our height is 3 over 3, cancel. So our volume is going to be 11 meters cubed. Our base here, that's not the radius, that 11 squared, that's the area of the base. Why? Because of that little meter squared right there. So that's 11 times our height of 3. And that's 33 meters cubed. So you're going to notice something here. Our volume of our cone is 11. Volume of our cylinder is 33. Therefore, the volume of the cylinder compared to the cone, you see, is 3 times the cone. And because, ask yourself, under what circumstance is this true? Is it only true for this cylinder and cone? Is it true for all cylinder or cones? Or is it true for cylinders and cones with congruent bases and equal heights? To know which one, look at the starting information. Starting information, there's a little hint here. It says equal heights, and then we noticed the bases were both 11. So this is true only because the base area was the same and the height was the same. Trucking company needs to move a pile of sand. The sand is stored in a shape like a cone. Pile is 7 yards high. Its base diameter is 10 yards. How many truckloads will the company need if each truck holds 4.71 yards cubed of sand? Use exactly 3.14. Always draw a picture. So we got piles of sand, and they're assuming they're a perfect cone. Probably not, but close enough. So there's our sand. Sand is stored. It's a cone, 9 yards high. Technically, that should be dotted. So we got that. Base diameter, 10, which means our radius is 5 and 5. Each truckload holds 4.71 yards cubed of sand. You're the one scheduling the trucks. So we're asking, how many truckloads is it? How many truckloads? How many times, if you only have one truck, how many times does it have to go back and forth to deliver this sand? Base, shade your base. Our base here is pi r squared, so that's going to be 5 squared times 3.14 times our height, which is 9, divided by 3. It's 25 times exactly 3.14, howdy, times by 9, divide by 3. So my total volume for that pile of sand is 235.5. That's yards cubed. And each truckload covers 4.71 yards cubed. How many trucks? That's a division concept. And it's going to take 50 truckloads. 50 truckloads. Back and forth, 50 loads. A silo is in the shape of a cone. A silo is 9 meters tall. So always start drawing. The minute you start reading a word problem, you should be drawing. So the silo is in the shape of a cone. 9 meters tall. Base radius of 2 meters, that's a radius. Wheat costs $2.35 per cubic meter. 232, excuse me, per meter cube. And it's asking, how much would it cost to fill this silo? Our base here is 2 squared times pi times our height, which is 9, over 3. So I'm going to cancel this out. I'm going to take the 3 into the 9, make it easy. Or easier. Oh. So this is 4 times 3.14 times 3. 37.68. So for every, do not round your answer, for every meter cubed, we're spending that amount of money. we're going to be spending $8,741.76 to fill that silo. Said the diameter of the sphere, 10.6 equals diameter. Instantly find the radius. Our radius is going to be 5.3. We're going to find surface area. Said round your answer to the nearest tenth. So 5.3, we're squaring that, times exactly and only 3.14, times by 4, rounding to the tens place is 352.8. And our units, millimeters squared. That's our surface area. Our radius, 7.7. We're going to calculate the sphere's volume. Do not round any immediate answers. Make sure you use exactly 3.14 for pi. Don't forget to divide by 3 at the very end. So I would hit the equals button in between, so that's 7.7 cubed equals times by 4 equals divide by 3 equals. Rounded to the tens place, which is the first decimal, 1911.4. Meters, and that's going to be cubed for volume. Chocolate company makes candies in the shape of a sphere, so the chocolate candies are like this. Each candy has a diameter of 6 centimeters. It's a big candy. That means our radius is 3 centimeters. Box contains 15, so we have 15 candies. How much chocolate does it contain? That's a volume question. Okay, the reason why I wrote 3 times 3 times 3 out, because we're over 3, you can see right off the key to multiplying is not multiplying, it's factoring. That's the one thing that I want you guys to really strive to understand about your own position. So this is basically 4 times 9, which is 36 pi. So 36 times 3.14, make sure you get exactly 3.14. There is the volume of 1 candy, but we have 15. So it's 1,695.6. Volume equals Check for units. And that is cm cubed.